Okay, so you know how like when you walk into an elevator, right?
Mm-hmm.
And you just kind of instantly know, do I press the button with the big 2 on it or the little, -3s, like integers in action, right? They're just everywhere, these positive and negative whole numbers.
Mm.
But I got to say, I haven't really given them much thought since, well, probably the last time I was trying to figure out my bank balance after a weekend trip, to be honest.
Yeah.
So we're taking a deep dive today. You brought in this textbook chapter. It's called Integers, looking for a little refresher course. And I am here for it. Like, it's amazing how much depth there is to uncover, even in the things we think we know.
That's so true. We use integers all the time. We don't even think about it.
Right.
But they're not just about counting, are they?
Right.
There's more to it.
Yeah, it's like they hold the secret to, like, how things move, how quantities change.
Exactly. Integers, they represent direction and magnitude, and that is crucial. Like, -5 isn't just less than 5.
Right.
It's 5 steps in the opposite direction.
I see.
And this textbook chapter you've got, it starts right there.
Yeah.
That basic definition of integers. So we're talking about positive and negative whole numbers, with our good friend 0 holding it all together in the middle.
Our good friend 0. We
Yep.
can't forget about 0. But, okay, this whole direction and magnitude thing, this is where it starts to click for me. It's like integers aren't just points on a line. They're movements.
Yeah.
Like forces, almost.
Precisely. And you know what? The source uses number lines to really illustrate this beautifully.
Okay.
You might think, number lines? Really?
Yeah, I was going to say.
But think about it. On a number line, you instantly see that -5 is less than -1, even though 5 is greater than 1.
Mm-hmm.
It's that visual representation of direction that makes a world of difference.
Okay, that's making sense. It's like a visual ranking system, but with direction baked in. And once you kind of get that, then you can see how all the basic operations work, like addition, subtraction, even multiplication, division. It all kind of flows from this idea of direction and magnitude.
Absolutely. And those rules about signs that we kind of just like memorize, like a negative times a negative equals a positive, suddenly it's not just a rule, it's intuitive.
Okay, I got to ask, why does a negative times a negative equal a positive? It's one of those things, like you memorize it, but like I've never really fully grasped the why.
It all comes back to that idea of direction on the number line.
Okay.
So think of multiplying by a negative number as like flipping the direction.
Okay.
So if you multiply a positive number by -1, you're flipping it from the positive side of the number line over to the negative side.
Okay, yeah.
And then when you multiply a negative number by -1, you flip it back to the positive side.
Oh.
So 2 flips, a negative times a negative, brings you right back to the positive.
Whoa, mind blown. So it's like these rules, they're not arbitrary. They're like reflections of this deeper logic. And speaking of logic, the chapter goes into these fascinating patterns that emerge when you start playing with integers.
Yeah, exactly. And these patterns are like these little clues, and they're revealing even deeper mathematical truths. For instance, the source points out that the product of an even number of negative integers is always positive.
Okay, now that one just sounds like a magic trick, like 2 wrongs make a right, but mathematically speaking.
Right.
So give me an example. How does that actually work?
Okay, so picture this. You've got your number line.
Okay, got it, yeah.
Each negative sign is like a flip.
Okay.
So if we're multiplying -2 and -4, we're starting at +2, flip once to get to -2, flip again, and bam, we land at +8.
I see, yeah.
Even number of flips, always back to the positive side.
Okay, that visual really helps. It's like suddenly I'm not just memorizing the rule, I'm like seeing it in action.
Exactly. And these patterns, they actually connect to these like broader mathematical concepts. Like that whole flipping action of multiplying by -1, that's the multiplicative inverse in a nutshell. And the fact that an even number of flicks brings you back to where you started, that kind of hints at the whole cyclic nature of multiplication when you're dealing with these negative numbers.
So there's like this hidden layer of elegance to integers, and these patterns are like little windows into that. But the textbook chapter, it goes even further, right? It talks about the properties of integers, things like commutative, associative, distributive, and honestly, those always seemed a bit abstract to me.
They can seem that way, it's true, but
Yeah.
you're using these properties all the time, you just don't realize it.
Really?
Oh, yeah.
Yeah.
They're like the backbone of how we manipulate numbers.
So-
For example, When you rearrange numbers to make addition easier, like, grouping 2 and 8 together and 2 plus 7 plus 8,
Yeah.
you're instinctively using the associative property.
Oh.
Or when you break down a multiplication problem like, say, 15 times 6 into 10 times 6 plus 5 times 6, you're tapping into the distributive property. You're like a math whiz in disguise.
I love that. Secret math whizzes we all are. But it's easy to lose sight of that when you get into the kind of abstract language of, like, properties. Like, how does this apply in the real world? Thankfully, the chapter, it gives us some concrete examples, like that one with the shopkeeper and the profit and loss, That really brought it home for me.
Oh, it's a classic for a reason. So the shopkeeper uses positive integers to represent profit, negative integers for any losses.
Right? Makes sense.
But what's so cool about it is that it shows how just knowing the total profit or loss at the end, that's not enough. The shopkeeper needs integers to track each transaction, to understand the ebb and flow of their gains and losses throughout the day.
Right. It's like you could have a day with a bunch of small profits and then one big loss, or a day with, like, a few big profits that outweigh some minor losses. Integers let you see that whole picture, make those informed decisions.
Precisely. And it's not just about finance. Think about temperature. That's another place where the direction part of integers is crucial. -5 degrees. That's not just a bit less than 5 degrees. It's a whole different world of cold.
Oh, totally. Integers add that extra dimension to our understanding. Temperature, altitude, even like time differences when you think about time zones, they really are everywhere. But we haven't even touched on, like, division with integers yet, have we?
Division. Well, it follows a similar logic to multiplication when it comes to the signs.
Okay.
Positive divided by a negative is negative, just like a negative multiplied by a positive is negative. And of course, the source reminds us of that all-important rule: never, ever divide by 0.
Right, that's a big no-no. Like, division by 0, undefined. It's like the universe breaks down or something. But I'm curious, we've talked so much about positive and negative integers, but what about 0 itself? We kind of glossed over it at the beginning, but I feel like it plays a much bigger role than we're giving it credit for.
You're right to zero in on 0. Pun intended, of course.
Yeah.
But it's true. It's often overlooked. But 0 is like the linchpin of the whole system of integers.
It's like it's both nothing and everything at the same time,
Yeah.
Like the textbook kind of breezes past it, but I feel like there's a deeper dive to be had here. What's so special about 0?
That's the beauty of this deep dive, isn't it?
Yeah.
We're uncovering questions as much as answers. You see, 0, it's like the neutral ground in the world of integers.
Right.
It's the point of reference for all those movements and magnitudes we've been talking about.
Okay, yeah, I can see that. Like on the number line, 0 is the starting point. It's like the center of it all.
Exactly. And you know what's fascinating?
Is that?
What happens when you introduce 0 into operations? Think about adding or subtracting 0 from an integer.
Yeah.
The value, it stays the same. It's like 0 has no power to actually change the direction or the magnitude, only to affirm it in a way.
Okay, but what about multiplication? If 0 has no value, then anything multiplied by 0 should also have no value.
Right. Now you're getting to the heart of it. This is where 0's unique properties really come into play. You see, multiplication by 0, it doesn't actually distribute value, it absorbs it.
Okay.
Think of it like this. Multiplying by 2, that's like doubling something. Multiplying by 3, you're tripling it. Multiplying by 0, it's like saying, give me 0 sets of that. No matter how much you start with, 0 sets of anything is always going to be nothing.
Okay, yeah, that makes sense. So it's not that 0 just represents an absence of value. It's like it has this almost active power to nullify. It's like the black hole of integers.
I love that analogy. And this might sound strange, but in a way, 0 is as important to our number system as the number 1. Oh yeah, 1 gives us a unit to build with, but 0 gives us a place to start building, a way to actually represent nothingness. Without 0, the entire concept of negative numbers, of going below a certain point, it would be so much harder to grasp.
Wow, I never thought of it that way. 0 is like the foundation upon which this entire system of integers rests. This deep dive has really opened my eyes. Integers aren't just these abstract concepts we learned in school. They're fundamental to how we understand and navigate the world.
Exactly, and I think that's what's so amazing. The more we explore, the more we realize there's always more to discover. Even something as seemingly simple as 0 can spark these really fascinating questions.
So true. So next time I'm staring blankly at an elevator panel or trying to decode my bank statement, I'm going to remember that there's this whole hidden world of elegance and logic behind those numbers. Thanks to this deep dive, integers will never seem quite the same again.